Alright. So we are in the new year now. It's get used to writing 17. So we are 1-3-17 for those of you who date your notes, which we all should. Couple things to point out as we transition back into class. I have upgraded from my upside down bucket. So no longer do we have the Homer bucket. So all of this stuff is for you guys to use. And these are leftover Gaga Pit pieces. So these are the wall pieces from the Gaga Pit. Yes, stain and polyurethane. So these angles, and we'll talk about the math of these angles when we get to that point, but these angles were cut to make an octagon. When two of them meet up together, they perfectly made the corner of the octagon. So, Post-its. I know often you run out of space on your notes if you write big like I do at least. So, big Post-its, little Post-its, pens, pencils, highlighters, colored pencils, pencil sharpener, ruler, calculators, graph paper, everything your heart could ever desire. I know. So, none of this, I don't have it, or no. If you don't have it, and it's not there, ask me. I'll figure out a way to get it there. I probably need to get a few more highlighters, but if you don't have any highlighters of your own, you need to have them. They were on your supply list. So, all of that to say, our resource center there in the middle of the room. Who can remind us what we've been doing in Chapter 8? So, the name of this lesson should help you remember. If you take out those middle two words, solving equations, right? So, solving equations, I have a really fancy way to say what we're doing. We're doing this whole process to get a variable by itself. What's that fancy word that I use to talk about being by itself? Yeah, but there's a really fancy word. If you get in trouble, like if you're in jail or something, you get in trouble, they might put you away all by yourself. You would be in
Isolated.
Yes, but isolated. So, we're trying to isolate these variable terms. So think about a scale. And actually, if someone reminds me, I will show you guys tomorrow, or if we have time at the end of class, I'll show you this really funny skit from Monty Python dealing with a scale. Anyone seen Monty Python, The Quest of the Holy Grail? You know the scale scene that I'm talking about? Yeah. So think about a balance. If you've never seen a balance, back in the old days, they would have these big like tower things in the middle. They would have two things that come off to the side, and they would drop down like baskets, kind of. And you would balance out like how many chickens for how many goats or things like that, like literally. Or a certain amount of weight of gold to a certain amount of weight that we know is a certain weight. So we'd balance. So right now, imagine this balance. I want you guys to draw a picture. So we're starting here a little artsy. So if you want to draw like a little tower and then like a bar across the top. And then all of these are on this side and all of these are on this side. Yeah, we're getting artsy. But don't worry, I'm really bad at art, so I don't expect any better from you. I guess if you want to draw a different version of a balance, you could also do the balance that has a base at the bottom. So you could do like a plate over here, and a plate over here. You could say that this. Something like that, I don't know. So, here's the trick about a balance. If I do something to one side, like, let's say I have two sides balanced, and I let a pen fall off of this side. That makes this side lighter, and it goes up. So what would need to happen to bring my balance back to balance? But I can't get that pen back. Take away a pen from this side, and now I'm back to balance. So, the trick with our equations is what we do to one side, we got to do to the other. So if I'm trying to get the x's by themselves over here, what would need to happen to the left-hand side to start working toward getting those x's by themselves? Xavier? Take off. What over there is not variables? The what? The ones. How do I get rid of those ones? Take them away. So the first thing we're going to do really quick right here is represent what we have via writing. So I know I already asked you to draw here. So over here, let's go ahead and represent our equation. On the left-hand side, I have 3x. I also have on the left-hand side positive 2. That's equal right now or balanced with, well, if I count all these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we get 3x plus 2. Sorry, not 12. 11. That's what I get for looking away. It's much easier to stay awake if you sit up. So Xavier already told me what I got to do. I got to take 2 away. I suggest changing colors or writing this in a highlighter or something like that here to show your brain I'm doing this action to both sides. That's what we're doing. So now what we have left is 3x on the left-hand side equals, what did my right-hand side become? 9, right? Because I had 11 and I took away those 2, so I get 9. Now, Shane, we got to remember how we get rid of things that are multiplied by our variable. What could we do to get that x by itself here now? Divide by 3. So what we're essentially doing is saying if I have this lump on the left-hand side, 3x, if I cut it into thirds, each one will be an x. So if I cut it into thirds, then we get that x is equal to 3. Any questions on what we just did? All right, try the got it on your own. Help, please stick my hand. We always want to undo the arithmetic first. So undoing addition and subtraction is always first, then undoing multiplication and division. So Lily, what is it that we would want to do first here then?
Okay, so I just wrote the same thing over because I made it bigger. Okay, so the first thing I did was to the 5, I added 5 because it's minus.
Yeah, because we have a minus 5, we need to add 5.
And I just crossed out 5 because you don't really.
Yeah, so we can say, okay, these disappear. I don't care about those.
So I put 6x equals 24, and then I was about to do 6 divided by 6, do the same with x, and then 24 divided by 6 is 4.
So we get, in the end, x is equal to 4. Any questions on that? It's not 5 though, it's a negative 5 plus 5, and that wipes out to 0. You're right. It's negative or minus. Just can't be both at the same time.
No, instead of, because I didn't see that it was negative.
Oh, you did minus 5? Oh, yeah. So, anyone not able to correct any other mistakes? Anyone have any questions remaining? All right, now, so here's the interesting thing. In this next solving a two-step, we've got a two-step equation that actually has a division involved. So the difference here, actually, can anyone just talk through the whole process? Immediately the boom, 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 we're going to do these things. All right, let's get started with one step then. Grace. Yeah, she totally just left the room. I was looking around where is she? Abby.
Yeah.
What would we do first here for solving these? It actually breaks it down step 1, step 2, step 3. So step 1, it tells me we want to.
This is undo addition or subtraction.
Undo addition, subtraction, right? So which do I have? Do I have addition or subtraction here? I have an addition. So we undo that addition by doing what? Subtracting. What is being added?
1.5.
So that's what we have to subtract. So on our paper, we want to write minus the 1.5 on both sides. If it helps you, draw that dotted line down the middle to separate your left side from your right side. If that helps you.
Something's kind of stuck.
Vacuum. Thanks. But I can't do it on my own, but watch if I set it back down, it'll do it again.
Is that what again?
Yeah. Had to buy the Phoenix one. Alright, so then that gives me x divided by 3 equal to our 1.25. So then, Justin, what do I do to get the x by itself?
Divide by 1.5.
So that's gone. We subtracted it because it was being added. So now we're here. What's being done with the x right now?
Divided by 3.
It's being divided by 3. How do we undo that?
Multiply by 3.
Multiply by 3. So we want to multiply by 3 over here and multiply by 3 over here. That will solve out to give me that x must equal 3.75. Now, especially because you don't want to waste your time on your homework or on your test or anything like that, checking your answer verifies immediately, are we right? You don't even have to write this out. You can do it in a calculator. But what you're going to do in the calculator is take your 3.75 and plug it in for the x. So you'll type in 3.75 divided by 3 and then add 1.5 with it and see, does it equal 2.75? If it does, we're right. So can somebody check that for us and see, does that equal 2.75? You got a calculator? Sure. Yeah.
How did you get x by 6?
So we had x divided by 3. We, to compensate for the division by 3, multiplied by 3. And we can think of multiplying by 3 as 3 over 1. Remember, putting 3 over 1 doesn't change anything. The 3 on top and bottom cancel each other out, and I get just x. Or you can think of this as a third of x times 3. Well, 3/3 is a whole. Does that make sense? So there was division that was going to happen. We stopped it from happening by multiplying. So, did anyone check this? Did we get 2.75? And we know we're good. So if it checks out, we know we're good. Try the example and the got it on your own down here. Try the example and the got it on your own. Plus. So my wife doesn't work today. I texted her, can you please bring a fan over here? I took it home for break. It's okay now, but it was really hot. Who needs more? Who just needs more time for the got it? Like you're good on the example. Anyone need help on the example? I don't need help on the example. You don't need one. What do you need? Oh, over here? Or over here? So the first thing you want to do is undo any of that addition subtraction. So you have subtraction, we want to undo that with addition. So like you showed, but we do it to both sides. Oh, okay. So we have 5b equals 30. So still, you might want to clean up your handwriting a little bit. What's going on with the b? What's being done to it? It's being multiplied, or it's trying to be multiplied. We stop that from happening by setting up a, so we divide on both sides by that value that we're trying to cancel. If you're still working on the got it, go ahead and continue. But Bella, could you tell me? Is she like playing hooky or is she sick?
I don't know.
Well, I heard that Jeremiah's like in Tampa or somewhere like that. Panama, that's where. Is he in like actual Panama or Panama City?
No,
He could have taken us with him.
I know.
All right, Hayden, you're here. I appreciate that you're here, bud. Hayden, what do you do first in this example?
You add 3.75.
Yeah. Guys, if you are still struggling on this, you want to highlight, circle, star, something, this box right here. This is your go-to for what's my process. We want to undo addition or subtraction. So Hayden told me, add 3.75 to both sides. Guys, it might help you if you draw that dotted line down the middle so you remember there's a left side and there's a right side. When I talk about doing things, I have to do it to both. It doesn't have to be dotted, but solid kind of confuses me, so that's up to you. So then we get 5b on the left-hand side equals 30. And CJ, to get the b by itself, we then want to divide by 5 on both sides. And b equals 6. And if we plug that back in, it will check out to be correct. Any questions on that? Sweet. Anyone need more time when they got it? Okay, take 30 seconds, maybe a minute. Give you a little bit more time. If you're done with the got it, go ahead and flip to the back and see if you can solve any of those. All right. Atticus, when we look at this got it, what's the first thing we want to do to work towards getting k by itself? Yeah, we have an addition, so we need to subtract. What do we subtract by? Yeah, we subtract by our 7.3. Now, conveniently, that cancels out the decimal on the left-hand side, or on the right-hand side. So I get k divided by 2 equal to 22. We then, Izzy, need to do what? We need to multiply by 2 over here, and multiply the other side by 2. You get k is 44. If we were to plug that back in, we would get the correct answer. Because 44 divided by 2 would give me 22, plus 7.3 would give me 29.3. Any questions on that? Anything else from the whole front? Flip to the back. So in these boxes, and if you worked ahead, if you worked ahead, you probably didn't know what was going on. So hopefully you didn't fill anything in here. We want to write what lets us go from the previous step to the current step. So the first thing in math, and you'll get used to hearing this a lot, is something that is given to you. It's just your start. So this is our given, which is really just our start problem. Sure, yeah. Yep, given or start. I mean, write given, but then if you want to put the start in parentheses, you can. You don't have to. The given is where we begin. It has been given to me. So then, what is it that we do to get from the given step to the next step? Xavier, what is being done? And up on the screen, it's in blue. Well, what's being done? Adding. And because it's being done to both sides, we actually call that, and we'll abbreviate addition with just add, but go ahead and put the period because technically it's addition. That's the addition property of equality. And the addition property of equality said back in like 8.1, as long as I add to both sides, right there, right there, nothing has technically changed. As long as I add to both sides, nothing has technically changed. It's going to look different, but we're still equal. My left side is still equal to my right side. So then, to go from here to here, all they did was combine the addition and combine the addition. So there, all we would write is simplify. All they did was simplify. They combined this to make 0, and they combined these to make their 30. Now, Grace, you're back now. What are we doing from 5b equal to 30 to get to the next step? Yeah, and because we do it to both sides, it becomes the division property of equality. And the last thing we do, anyone have a guess? Simplify. You just do the math. This is a great reference as you're doing your homework to say, am I doing the process right? It's done out for you with pretty much as much detail as you could ask for. So if you struggle on your homework, come back to here, use this as a reference. Any questions on this? All right. We now need to set up a situation for down below. So I want you guys to underline or highlight, I'd prefer highlight, the important parts of this situation. So Julia, as you start to kind of dig into this problem, what seems important to you?
I highlighted how much each ticket costs.
Yeah. So each ticket costs $39.95.
And then the processing fee.
Processing fee of $12.75.
And the total cost.
And the total cost, I'm going to go ahead and change color for that.
And the question.
Oh, and the question, yeah. Right, it's all to find the number of tickets. Yeah. In this order. So we're solving for number of tickets. Now we got to write this out. Now what we know is a total cost. So what goes into making my total cost? That's what we got to figure out. So Flynn, when you order this, what goes into the total cost? What all do you have to pay for?
The fee and the cost.
Yeah, so the fee and then the cost of, what are we buying? Yeah, the ticket cost. So we have tickets, and I just think of the tickets first because there's no fee if you don't buy tickets. So we have tickets, and then we have to pay a fee, and that's going to equal our total cost. So our tickets and our fee will equal our total cost. I love your sweater. It's a tessellation. Did you guys do tessellations in elementary school where you copy a shape infinitely? Yeah. Search it up if you don't know what it is. Heck, you'd be really interested in it. MC Escher does a lot of tessellations, art stuff. Yeah, MC Escher is a mathematician artist. He's dead now. Yeah, but he's sweet.
Oh, okay.
Well, I mean, Einstein was a really cool guy. He's dead now. Newton, great guy, dead now. So, Michaela, shh, what am I spending on the tickets? What am I spending on the tickets, Michaela? $39.95. Now, do I only, and I know this says words, but I'm going to start doing my numbers up here. Do I only buy one ticket? No. But we don't know how many we order. So at $39.95 times the number of tickets, I'm going to use N because I hate the variable T. So I'm going to use N for number of tickets. Now, fortunately for us, we only pay the processing fee once. So what's our processing fee? $12.75. That's not that bad, actually. Like, I know it sucks because it's just a fee, but that's not terrible. And the total, we know we can fill in $212.50. So now, Andrew's still vacationing.
No, I don't know if he's in like a different class.
Circus.
Yeah, he's here.
Where's Andrew?
Jaheen, what will be the first thing that I want to do to start working towards getting the N by itself? You flip back to the front and look at that little box that tells you the process. Step 1 is always undo addition, subtraction. So we have addition, we need to subtract. What do we subtract by? Is that what is being added? No, the thing being added is the $12.75. That's what we subtract. I would use a different color if I was you. I would use a different color if I were me, too. So then we get $39.95. You're right. Thank you for the grammar correction. And this, kind of annoyingly, comes out to be $199 and... No, take away 75 cents from 50 cents. Get back to 75. That kind of looks weird because it's way disconnected. Then, Mr. Bontley, what do we do to get the N by itself? Yep, we divide 39.95 on both sides. And we get that the number of tickets that we ordered had to have been 5.
Wait, what?
So we ordered 5 tickets.
Okay.
Yeah, that's not a bad price depending on the concert.
What was the movie?
Concert tickets. A lot of you guys probably don't know this band, but I went and saw Van Halen, which is this old rock band, and their bass guitarist was like so old and like in bad health, he couldn't go on tour with them anymore because I mean they're an old group. So one of the dude's sons was playing bass for them, and he's like in high school. So this dude, his name's Wolfgang, but this high school kid is up there, and it was at the Schottenstein. So if you've ever been to the Schottenstein, it's this huge arena, and this dude's like 17 years old, just up there playing bass with this killer rock thing. Try this on your own. A boating club rents sailboats for $60 an hour. And $20 for each additional hour. So the first hour that you have it is more expensive because they got to make their money. But then every hour you keep it beyond the first hour is only $20. When you return the boat, your fee is $140. So first, think about what are we paying for and that equals 140. So try it on your own. If you can't figure it out, I'm going to shut up and I'm just going to write a couple things. So if you can't figure it out, glance up here. But try it on your own. So all I wrote down here is what I know. I know I pay $140. I know that what I pay is a first hour and then additional hours. That still equals 140. Then I know that my total hours will equal my 1 that I start with and some additional hours. Anyone know how I can set this up and write this? Abby?
Couldn't you do 60 and like a variable?
Now, does the 60 happen multiple times? But that 60 is the first hour. Can the first hour happen multiple times?
No, so when the 20
So the first hour, that only happens once. So this 60 is that happening once.
Yeah.
Then the 20 is for each additional hour.
So when it be like plus 20, but
A variable attached to it. Like what you were trying to do with the 60, but the 20 is what happens multiple times. And that equals 140. Think about the problem that we're solving. I know what I paid for the first hour. I want to know how many extra hours I kept the boat. So if I get rid of the first hour, I can solve for my additional hours. But to get rid of my first hour from both sides, Abby, I subtract the 60. That's what it cost me for my first hour. So now I figure out that my additional hours charge, my 20 times h, equals 80. What must h be? 4. It's got to be 4. Because when I do this division, and we can just think it out in our head, what times 20 equals 80? Well, that's going to be 4. But that's the solution for our variable. Ah.
How many hours was that?
Now, why did I say but? Is that how long you had the boat?
No.
plus the 60.
Hayden.
Find out plus the 60.
So I 64.
Plus that 1 hour.
So at first Hayden said, but wait, plus the 60. But that 60 was how much it cost for the hour. This 4 is the additional hours. So when I look at my total hours, it's the first hour plus 4 additional. My total was 5 hours. Maybe you went on an all-day fishing trip or something like that. I've not been fishing in a while. Why? No patience? Get out your binder. Get out your binder. I need you to check something because I want to give you a warning. JBL, one of my favorite sound companies. Their stuff is rock solid. We had speakers from JBL in college, and one fell off a pickup truck and rolled down the street. Worked totally fine.
Did you take it off of the
No, we were moving from one house to the next, and this speaker was not attached. Yeah, but I mean, you can't stop it. It's heavy. Go to your math section. Starting with this chapter, when you turn in your mastery, you're also going to turn in your notes. So when you look at your 8-1 and 8-2 from back before break, and now 8-3, the quality of which you fill in your notes is going to directly relate to whether you end up with a progressing or a mastery. So I'm also going to hand you out 8-4 now so that you have these for tomorrow and you can dive right into the lesson. But I want you to think about, are my notes quality work that I actually use while I'm doing my homework? And if they're not quality, you might need to get with a friend or somebody that took good notes and adjust them or go back and watch the videos. Because if you're only filling in like the answers or you're barely drawing anything, like you're going to end up with a progression for the chapter. Because we have plenty of time to write these things down. I guarantee none of you are running out of time. You might be running out of effort, but I guarantee you are not running out of time. So, yeah, so we have 4 minutes right now. I'm not going to start the next section. But we have 4 minutes. But I want you to look at your binder, and you can look at more than just math if your math is good. But think to yourself, if I were to take out my Chapter 8 notes and hand them to Mr. Hudson right now, what do you think I would say about it? Do you think I'd be like, oh, great job, I see you got everything down here, you're highlighting, you're using colors, that's awesome. Would it be, hey man, you barely have pencil on here, let alone any colors or anything like that? Think about, are your notes quality? That is. So when I say there's a jar of highlighters, get highlighters, highlight this, you're directly just ignoring them. So that needs to be adjusted. Me telling you to highlight things is not asking, it's telling. So as we move forward, think about that as we go. You've got a couple minutes so you can compare with friends or whatever else if you want to check your notes versus their notes.
How was your break?
Good. Too fast. Got projects on those shelves were like my Discovery Day project.